to Tyler. It's very gracious. Hopefully I think some of you are benefiting from that, which is good. Okay, so this is the problem we left off on. Can those at home see the notes? Can you guys see the notes?
Yeah, we can see them.
Okay, perfect. Okay, this is a problem we left off on. So quick review. And actually, one thing I'm going to do tomorrow is I want to look at the Princeton Review. I want to go over that a little bit and kind of talk about here are sections that I really would encourage you guys to cover first, and to kind of save some of the units till as we get more into April, late March and April. But what we're doing is equilibrium. Okay, so we're talking about reversible reaction. The equilibrium constant expression, so products on top, reactants on the bottom. Solids and liquids we don't include. We write one in their place. The coefficients become the exponents. Okay, and then the process. So first we wrote the expression. So products on top, reactants on the bottom. Coefficients became exponents. Solids and liquids were not included. We did nothing with numbers. Then we were just given the equilibrium concentrations. We just plugged in the numbers. That wasn't too bad. Then we got yesterday where we said, okay, here's our initial concentration, here's our equilibrium concentration, and we started ice tables. And then we had this thing Q, and actually this that I got on the overhead, I am pretty sure I did yesterday the question about which direction will equilibrium proceed. Did I do that? I think I did. And we said that the value for Q was 19.45. And remember, we put them on a number line. So if I do that, this is the way that makes the most sense to me. So here's K, which is 54.3. I determined Q to be 19.45. And remember, Q always moves towards K. And so so this is the answer to that first question. This is going to proceed to the right. Okay, so here's our monster question. I'm going to tell you right now, doing this problem, I will never give you one like this, because to do this, I'm going to need to use the quadratic equation. Now, I'll tell you, I'm working right now on the test. I was actually working on it just a few minutes ago, the test that we're going to take after spring break. And I always typically will throw one in like this second problem on our test, but I will make it extra credit. Okay, so you're not going to have to do it, and I'll show you why. So the question is to determine the final or equilibrium concentration of each species. So if I go back, and this is going to be an ice table problem. Okay, so here's our equation. And remember what I said in an ice table, almost all the time, and really, to be honest with you, all the time for us, initial, change, equilibrium. Start, change, end up. And on the reactant side, we're going to have an initial amount. But on the equilibrium side, it'll be zero, except for this problem. And I think, again, this is the one that's going to be extra credit. But what I've got here, so the H2 is 0.00623. The I2 is 0.00414. And this is what's kind of unusual about this, is I do have an initial amount. If you look at the top, it says that the initial concentration of each reactant in the above equation. So we're given all the concentrations. But now, since we've determined that this is going to the right, this is going to be consumed, and this is going to be made. So this is going to be minus x, 1 to 1. This would be x as well. And again, I'm using this term, we're going in the fire swamp. This, to me, is a really good problem, period. Okay, this is way, way beyond first-year chem. Okay, so if this is x and this is x being consumed, look at the coefficient ratio, the stoichiometric ratio, 1 to 2, 1 to 2. What would this be? 2x. Very good, Tyler. Okay, so what I've got then, is I've got my equilibrium constant, which is 54.3. That's the value that's given to us in the problem. And I have HI, so if I just write out the expression, so the product on top and then the reactants on the bottom. These would be to the first. Okay, now I plug in the numbers. So I got 0.0224 plus 2x squared. This is where it's starting to get, to me, really messy. And you guys probably, a lot of you, maybe not, maybe all of you, on your calculators could do this better than I can. So if I plug in the H2, is 0.00623 minus x, and the I2 is 0.00414. So I did what I did here, and again, when you're doing these are why I'm saying, to me, the best thing to do is to write these out. Writing, I think, is really a good thing to do. And try and do, what do we know? Okay, we know, we knew this was the equation, and then again, the ice table was definitely a little bit confusing. Okay, now you guys help me out, those here in class and those at home. So if I want to combine these terms, what do you call it? The outer, or no, how do you do this? What's FOIL? So first, and then we do
the outside.
Right, so we do the outside, and then we do here, here, here. Am I right? Am I right? Does anybody remember? Ethan, I think Allie's saying it. So if I do the same thing here, so if I have this is, if it's squared, what this is this called, Allie, is it called FOIL? So first, is this FOIL?
Yeah.
And then we go here, and then we go here, and then we go here. Am I right?
I mean, yes. You're just doing the outside first. Because you went the whole way around. So
Okay.
you're doing the outside first. But like.
Okay, so I could have done the first,
yeah,
the outer, the inner,
and then the last one.
Okay. Okay, so if I combine this, I did this actually before class. So if I combine this, so what I get, and then I cross, remember I have the 54.3. So if I do, again, the first, the outer, the inner, and the last, and then I cross multiply. So if I take 0.00623 times 0.00414, I get, so I have 54.3. And then again, so this times this, so the first gives me 2.58 times 10 to the negative 5th. Okay, so that was this times this. Okay, and then the outer, so if I took this and this, so that's the inner, am I right, Allie? And I combine those, I get 0.014x. And then the last, I get plus x squared. Okay, let me slow down here. Kyle's going, wait, this is chemistry class, it's not math class. He would be making a pretty good point. Are we okay on that? At home, are we okay? Okay, so are we okay? I hear rattling.
Yeah, we're good.
We're okay. So I'm doing the same thing. So first, outer, inner, and last. So if I do that, what I'm going to get, so this times this is going to give me 5.02 times 10 to the negative 4. And then if I combine the outer and the inner, I get 0.0896x. And then the last, I get 4x squared. For those that are following along, nobody in class is. Alex maybe is. I don't know if anybody is. We okay? Does this all look right to you? Ethan, does that look right to you? Other than without using your calculator. Does it look right? Allie?
So I'm just confused on where you got like the two parentheses that you just spoiled right now. They're the same.
You mean what parentheses you talking about?
Right, and then like kind of like in the
Here?
middle. Nope, up, right.
Here? What I did is I just squared this out.
Oh, gotcha.
I just showed this
Okay.
squared. Okay, so then if I combine everything, so if I distribute the 54.3, and I solve for everything, this is what I get. So I have 50.3 times 10 squared minus 0.654 x plus 8.98 times 10 to the negative 4 equals 0. So what I did here is I distributed the 54.3, and then I just combined all the terms. And now we're at the place with the quadratic equation. So we have A, B, and C. Hopefully, nobody in class is checking me on this. Hopefully somebody at home might be checking me on this. It would be good. Okay, so then the quadratic equation. So I'm going to go back up here. Karen Mason, make sure you're telling me if you can't see something. So here's the quadratic equation. And students in the past have told me, you guys on your calculator can do this. Am I right? I get absolutely no response in class. Can you guys do this on your calculator? Tyler, can you do this on your calculator? I think, isn't there a way you do this on your calculator? David, am I right? I don't know. I don't know if there's not. I'm old school. So I've got A, B, C. Karen Mason, you can see both the top of the board and the bottom of the board. We okay?
Yes.
Okay. So then I plug in, and what I get here, plus or minus, I end up getting 0.0114 or 0.00156. So you go through the whole process. And again, so like, remember when I started this problem, I told you I will give you one like this on the test, but I'll make it extra credit. So it's not one, if you're like, oh my gosh, I'm really lost here, then don't worry about it. But we're doing some pretty good problems anyways. But you do have a chance for extra credit. Okay, so, and again, I worked this problem before class, and I'm pretty sure that I've done this correctly. Now, if you look at this, these two possible answers, only one of them is a possibility. One of these two is not a possibility. Remember, we go back here, and this was our H2, this was our I2, this was our HI. So this was H2 and I2 and HI. And if you look at this, just mathematically, one of them would not work. Which one would not work? One of these is not plausible. Like if I use, what I'm saying is if I use the bigger number and I put it here, I would have a negative concentration, right? That's not a possibility. So this one is not plausible. So this has to be the concentration. Am I right, Tyler? On your calculator, you can do the quadratic equation? I thought in previous years students told me that. Okay, so then the question referring back to the notes, now that I've solved for x, so x has to be this. This number's too big, it's going to give me a negative value. So now, to solve for the H2, I have 0.00623 minus x. So if I plug x in, what I get is 0.00623 minus 0.00156. And that gives me 0.00467. Okay, if I do the I2, I have 0.00414 minus x, so I have 0.00414 minus 0.00156, 0.00258. And then for the HI, what I had is 0.0224 plus 2x, so this is 0.0224 plus 2 times 0.00156, 0.02. These would all be molar. Okay, to me, that is a really good problem, really challenging problem. Like I said, we will, and one thing I remember a few years ago, I took actually 2 summers in a row to show you what a nerd I am. I actually did a week-long workshop on the AP test, and both of the people who taught it the 2 different times, they both said they will never give you the quadratic equation on the AP test. So I will not give it to you other than extra credit. So does that make a little bit of sense what I did there? Tyler, to you too? That's a monster. See, we're kind of got to look at it, right? Digest that. That's Kyle, to make sense to you, following along a little bit?
It like makes sense when you do it. Like,
But it's a monster.
It's like I probably couldn't do it by myself.
And this is why, to be honest with you, before I do the notes, I always go over it beforehand. And definitely today I knew I needed to. Okay, any questions then on that? Okay, I still want to do a couple more equilibrium problems. Okay, now this next one is one that's fair game. Fair game for not extra credit, just expect you to be able to do it. Okay, there's going to be a principle here I'm going to talk about that we're going to use. And again, I'm really hoping we can get into chapter 14 as well. But I'll talk about this principle. This is what's going to make the math a little bit less daunting.
Mr. Wood?
Yes?
How'd you know it wasn't the 0.014 again?
You know, if I had used Juliana, if I had put that for x here or here, I would have had a negative number.
Oh, okay.
It would have made it negative. That's a good question. And when you do quadratic in our class, you're going to have one number that is just, it's too big and you couldn't use it.
So how do you get those 2 numbers factoring in the calculator?
You have to actually plug in. So I've erased it. But what I had, Tyler, remember let me write it out again. So what I had, you just would truly have to use both. So what I had was this. This is what I had was equal to 0. So I had 0 is equal to 50.3 times 10 squared. That is the A. Minus 0.654x. That is the B. Plus 8.98 times 10 to the negative 4, and that is the C. And Tyler, I could be mistaken. I actually didn't do that on my calculator, but you go back and see this is where the plus or the minus, and that's why you'd have 2 possibilities.
Yeah. But like, where did you plug them in and simplify it by hand, or what? Since you didn't do it on your calculator.
That's the way I did it on hand. But I thought on your calculator there was but I could be wrong.
Okay.
But I just plugged in. So I plugged in the A, I plugged in the B,
Yeah,
the A, and the C, and then just work it out. Does that answer your question? Yeah. Okay. Okay, so now this next problem is, and again, I'm recording this, so if you have trouble sleeping these days, you can watch this, or you could, if somebody you know is having trouble sleeping, go, hey, I've got the solution. Watch my teacher teach an AP chemistry problem. They'll be sound asleep in just a couple of minutes. But if you wanted to go back and go over that, I'm recording this, you could see that. Okay, here is another problem, and this is going to introduce this thing called the 5% rule, which is something, again, this is why I really would like to do, because 16 and 17 are quicker chapters, and I know they'll be on the AP test, and then 14 and 15 are bigger chapters, especially 15, and we probably will not get to that, but we'll come to this in chapter 14. So if the question here is to calculate the partial pressure of all species when equilibrium is established. So if I do this here, so I've got N2 plus 3H2. This is a more typical equilibrium problem. Okay, so we're given the KP and we're given the initial amounts of the N2, so of the N2 and of the H2. So I have 0.862. I have 0.373. And again, the only time you wouldn't have 0 on the right side in the I row is a problem like the last one. So typically, it'll be 0. And we want to find, ultimately, we want to find the pressure of the N2, the H2, the NH3. So as awful as that last problem was, and it was pretty awful, this one is going to present some good news. So I'm just going to, just wait here a second. So if I go now to my ice table, and this is where I'm going to look at this, to me, the kind of the key thing in the ice table, and the I row, I have my initial amounts, so I'll have the reactant initial amounts. Over here, I'll have 0. The key thing is the C. So this is going to be minus X, because on the right, or on the left side, we're consuming this. This would be minus 3X, because it's 1 to 3. This would be plus 2X. So on the right side of the equation, in the C row, we're making, so it'd be plus 2X. Okay, so the KP, which they give us, is 4.31 times 10 to the negative 4th. I told you the fire swamp. This could really look fire swampish, which means in a scary place. So I'm just plugging in. So I have the NH3 squared, then the N2, and Alex and Tyler and Ethan and Allie and Kyle and David and everybody at home, you guys are way smarter than me. You might look at that and go, oh, piece of cake. I look at that, Alex, I know you're really bright. That looks awful. Mathematically, that looks awful to me. And so one thing we're going to do, and I'm going to talk about it now, and I'll come back again, hopefully in the middle of April, we'll spend some time in chapter 14, but there's a rule, David, that makes our life, as awful as it is in AP chemistry, a little bit easier. And that is if you take the concentration of the reactant, the initial concentration of the reactant, over the K value, and if that number is 100 or greater, you can ignore the X of the reactant. Okay, I'll say that again. So you take the concentration of the reactant over the K value. If that number is greater than 100, we ignore the X of the reactant. And I'll show you what I mean by that. But in a way, in the awful problems that we're doing here the last couple of days, this will make our life a little bit easier. And then at the end, we're going to check it with this thing called the 5% rule. So in this problem, if I take the concentration of the reactant, 0.862, over the K value, I think that comes out to be like 2,000. I'm saying if it's greater than 100, $2,000. So this is significantly greater than 100. That means I ignore the X of the reactants, not the X of the product. Really what that calculation is showing is X is going to be so small, we can ignore it for the reactants. So it's going to make our life way easier. So you take the concentration of the reactant over the K value, and if I did the same thing, so certainly you could ask a really good question. You go, well, how about the other reactant? Okay, well, let's do it. So I do 0.373 divided by 4.31 times 10 to the negative 4 is 865. Again, it is far greater than 100, which means I ignore X. And I ignore the X's of the reactants. So this is going to make this a little bit easier. So I got 4.31 times 10 to the negative 4 equals 2x squared. I'm not going to ignore the X of the product, but I am going to ignore these X's. So as smart as everybody is here in my class, as well as at home, Alex, as bright as you are, and Tyler and Ethan and Allie and Kyle and David, This looks a lot less scarier than this to me. Okay, solve for x. Solve for x on your calculators.
So you got the entire 3x.
I got-
not the x.
Yeah, I did.
Mr. Wood,
Yes.
for when you decide whether to like ignore the reactant, do you have to do it for all the reactants or do you just do it for one?
I would do it for all of them. Allie, Kara, I do it for all of them. And we're going to have, you'll see here after we do this, there's a way, so up front here at the beginning, we can do this ratio like you just asked about. And when we're done, we can do this thing called the 5% rule, which I'm going to show you on the next slide. But to answer your question, I would do both of the reactants if both are given. And I will tell you that in our class, in the AP test, on our test, the X's on the reactant side will always be ignored on required problems. Again, I'll give you an extra credit problem. Okay, so it'd be a good exercise to go through and do this. What I get for X is 0.00220. Can somebody in class or on the computer confirm with me that that is X, Tyler?
It just keeps giving me 0 when I try to do this. Maybe it's not like round.
I'm just curious. Anybody at home? Some people in here are punching their calculator here.
That's what I got.
Did you get that?
Yeah.
Okay, Juliana got it. I'm just going to wait a minute. It would be worth trying this. Again, to me, it got a lot less scary, but it was still kind of scary. Hey, Ethan and David, I don't know if Alex, you're trying it. You just get 0 on your calculator, Tyler? Did you get it, David? Okay, so David got it, and David and Juliana got it. I know that I'm in a good place. But that's not the answer. The question was, what is the pressure? So for the pressure of N2, so I go back here, I have 0.862. And this is why we can ignore X. So I have 0.862 minus X, which is going to give me, and so you can see that X is so small, I get 0.8. 0.862 minus 0.002. So I'm going to go 0.860. Got to go to the 100th. Okay, then if I do the pressure of the H2, so I have 0.373 minus 3x. So I have 0.373, 3 times 0.022. All I got there was 0.366. So again, you can see that X is really small, and this is why ignoring it is, I mean, we're talking about in the 1,000th spot. And then for the NH3, it's 2X. So it's 2 times 0.00220, which gives me 0.0044. This would be more. Now this problem, again, and I told you guys, these are problems that I think it would be really a good thing to do, to go back and to do these problems tonight. I said that about what we did in class yesterday. These are good problems. We are definitely into AP chemistry problem, fire swarm. Okay there? Okay, so I said up front, you can take the value of the reactant, if there's 2, like Kara asked, over K. If it's 100 or greater, then you can ignore X. If it's not, then you gotta factor X in. Now here is what you can do at the end. This is called the 5% rule. So up front, you could do this ratio I'm talking about. So you take the concentration of the reactant over the value for K. It's 100 or greater or near 100 or greater, ignore X, because we would like to ignore X. But then on the back end, we have the 5% rule. And this is just telling us that by ignoring the X, was that okay to do? And I'm going to do it. Kara asked a good question a few minutes ago. I'm going to do this for both of the reactants. So the way this is going to look, I don't want to go too fast here. I'd like to do one more problem after this. But so if I want to look at the percent of N2, so here's for the N2. So I'm going to take X 0.002. There's the value for X over my initial amount times 100. And just like it says here, if it's less than 5%, then ignoring X was okay. And so what I got here was 0.255. Well, that is significantly less than 5. So ignoring X was fine. Now, if I do it for the H2, so the H2 was 3 times 0.00 over 0.373. So we had 3x times 100. And I'll tell you, for us, in the problems we're doing here, and we're going to do one more equilibrium problem, and then we're going to be done with the ones I want to do in class. I want to kind of review it tomorrow. So you have a way up front you can check this, which is the 100% thing. So reactant over K value, if it's 100% or 100 or close to 100 or greater, ignore X. And then at the end, take the X value over your initial amount. And if it's less than 5%, we're okay. And you can see here's problems you guys can be working in class, or I'm sorry, from the textbook. Okay, last problem I want to do today. Well, I'll leave that up. Okay, one more equilibrium problem. Okay, I'll let you guys read this, and then we'll do it. And that'll leave us a good place tomorrow to go into the last topic, which you have a couple days on this thing called the Chatrier's principle. And again, this is why writing to me is really helpful. So we have 4 moles of SO2, 6 moles of O2 are mixed and sealed in a 1 liter container at equilibrium. This is a clue. We're in an ice problem. 1 mole of SO3 forms. Use the following chemical equation to determine the equilibrium concentration of each species and the value of Kc. So this, because again, I've got an initial amount and I got an equilibrium amount, this is an ice problem. So I have 4 moles of the SO2. I have 6 moles of O2. And remember, and because again, it's 1 liter, that means the moles equals the molarity. And remember, in the I row on the right side, I end with 0. But then it says, at equilibrium, 1 mole of SO3 forms. So that means I had 1 mole of SO3. Now remember, in the C row, I subtract, and in the C row is where we look at the mole ratio. So if it's 2 to 2, if this was 1, this would have been 1. And again, if it's 2 to 1, this would have been half as much. Half as much as that. So look at that again. So again, this is all kind of based on this 1 at equilibrium, which meant I would have added 1, so 2 to 2. But here I'm subtracting, but because it's 2 to 2, it would have been the same number. And 2 to 1, it would have been half that number. Okay, so the equilibrium amounts, there would have been the SO2, there would have been the O2, there would have been the SO3. And now for KC, I've got SO3 squared over SO2 squared times O2. So now I plug in the numbers. So I have 1 squared over 3 squared times 5.50. And again, it's already hard enough, and you just got to kind of watch yourself and make sure that you're remembering the squareds and the cubes and so on. So if I do this, that gives me 0.0202. So there's the value for K. And remember, K is one of those rare numbers we have that does not have a unit. Okay, and that's the last problem I had in class, and we've done some really good problems the last 2 days, and you know, we're definitely in the fire swamp in AP chemistry. Those that haven't seen The Princess Bride, if you ever have it's supposed to snow a bunch this weekend. I'm just telling you, watch The Princess Bride. Okay, I'm going to stop there. For those at home, you guys, if you want to hang on and you have questions, more than happy to answer your questions. But if you don't have any, you guys are free to sign off. And those in class, I told you to give you the last few minutes, but I need the quiz in this pile. I need the labs in this pile. And if you have questions, you can ask. So anything at home? Any questions you guys have?
Yeah, Mr. Wood, thank you.
See you, Mason. See you tomorrow.
Thank you,
Thank
Mr.
you.
Wood.
See you guys.
Thank you.
Tyler, you said you had questions on lab or quiz?
Yeah, percent error, do you use any 2 points?
Yeah, bring it up here. I'll show you. Use on the lab.
Yeah.
Here we go. Okay. Here are the labs. So
Does it matter which 2 points we use?
we want to use
Actual versus the accepted.
so percent error. So we're going to take